In the vast expanse of the cosmos, a remarkable observer emerged, a telescope that would forever change our perception of the universe. Join us on an extraordinary journey as we unravel the secrets of distant worlds and explore the untold stories of planetary systems beyond our own. Brace yourself for a cosmic odyssey as we embark on an awe-inspiring adventure with the Kepler Space Telescope, unveiling a tapestry of exoplanets, unveiling the mysteries of habitable zones, and unveiling the breathtaking diversity of our galactic neighborhood. NASA's Kepler Space Telescope was an observatory in space dedicated to finding planets outside our solar system, with a particular focus on finding planets that might resemble Earth. The observatory was in commission for just under 9 years, from its launch in March 2009 to its decommission on November 15, 2018. Since Kepler's launch, astronomers have discovered thousands of extrasolar planets, or exoplanets, through this telescope alone. Most of them are planets that are between the size of Earth and Neptune, which is 4 times the size of Earth. Many of these planets were discovered in a region of the constellation Cygnus, about the size of the palm of a hand held at arm's length, where Kepler was pointed for the first 4 years of its mission. How Kepler got its start. Kepler was the brainchild of NASA scientist William J. Borucki, who had worked on science instruments for the Apollo program. Starting in 1983, Borucki began advocating within NASA for a mission that would search for exoplanets by watching for transits, events in which a planet passes in front of its star as seen from Earth's point of view. Borucki's concept was rejected by NASA 4 times as the agency demanded various demonstrations that the mission was technologically and financially feasible. NASA finally approved the mission in 2001. Kepler was part of NASA's Discovery program, which funds lower-cost spacecraft for exploration of the solar system. Kepler was selected at the same time as Dawn, a spacecraft that visited the small worlds Vesta and Ceres. In a lecture at the Carl Sagan Institute at Cornell University, Borucki explained, "Kepler looks at over 170,000 stars simultaneously, looking for planets that cross their star and block some light. By the blocking of that light, we can tell how big the planet is compared to the star, and when it repeats, we can tell the orbital period. From Kepler's third law, we can deduce how far the planet is from the star. And by looking at the properties of the star, we can tell how hot that planet might be." Primary mission. The $600 million Kepler telescope was launched in 2009 with the expectation that it would operate for a year. In the early days, an important part of Kepler's operations was eliminating false positives. Because apparent star dimming can also take place through means other than exoplanet transits, for example, due to a star's natural variability, star spots, or another star or pair of stars somewhere in the same line of sight. Each candidate planet was confirmed through other telescopes, generally by measuring the gravitational wobble exhibited by a star in response to a revolving planet. But Kepler's original mission was not so much to identify individual exoplanets as it was to take a census of as many stars as possible and estimate the percentage of stars that host planets. So, as Kepler accumulated experience, statistical methods were brought into play. For example, in February 2014, astronomers pioneered a new technique called verification by multiplicity, which distinguishes multiple planet systems from multiple star systems and thus finds many exoplanets at once. Through this technique, the team unveiled 715 confirmed planets in one release, making the largest batch of planets in a single announcement up to that time. New mission. Within a few months, the agency came up with a new mission for the Space Telescope that it dubbed K2. The mission would use the sun's solar wind to stabilize the telescope for several months at a time. Then, about 4 times a year, the telescope, which is about 15 feet, 4.7 meters, long and 9 feet, 2.7 meters, in diameter, would turn to a different field of view when the sun got too close to its sensors. While the pace of planetary discovery was less with the new mission, new finds continued. In January 2016, NASA announced the discovery of more than 100 new planets based on K2 observations. This is a validation of the whole K2 program's ability to find large numbers of true, bona fide planets. Ian Crossfield, an astronomer at the University of Arizona, said during the American Astronomical Society's annual meeting, during which the find was announced. Kepler examined the TRAPPIST-1 system, which likely has multiple Earth-sized planets in it, between December 2016 and March 2017. That February, another team of astronomers announced more Earth-sized planets had been found. Kepler scientists then released the raw data from their TRAPPIST-1 observations for other teams to analyze if they were interested. In February 2018, NASA put out another release of Kepler data on 95 new planets found during the K2 mission. One of those planets was orbiting a bright star, making it an easy candidate for follow-up by a ground observatory. Kepler Space Telescope major discoveries. The Kepler Space Telescope, launched by NASA in 2009, revolutionized our understanding of exoplanets and unveiled a wealth of discoveries during its operational lifetime. Here are some of the major discoveries made by the Kepler Space Telescope. Exoplanet population. Kepler's primary mission was to search for exoplanets, and it did so with remarkable success. It discovered thousands of confirmed and candidate exoplanets, revealing the prevalence of planets beyond our solar system. Kepler's data demonstrated that there are likely billions of exoplanets in our Milky Way galaxy alone, suggesting that planetary systems are common throughout the universe. Habitable zone planets. Kepler identified a significant number of exoplanets orbiting within the habitable zone of their host stars. The habitable zone refers to the region around a star where conditions may allow liquid water to exist on the planet's surface, a key ingredient for life as we know it. Kepler's discoveries expanded our understanding of potentially habitable worlds and sparked further investigations into their atmospheres and potential for hosting life. Kepler 186f. One notable discovery was Kepler 186, the first confirmed Earth-sized exoplanet located within the habitable zone of its star. This finding was significant in the search for potentially habitable exoplanets and fueled speculation about the existence of Earth-like environments beyond our solar system. Exoplanet diversity. Kepler's observations revealed an astonishing diversity of exoplanets. It identified rocky planets, gas giants, super-Earths, and even planets in multiple star systems. This diversity challenged our previous assumptions about the types of planetary systems that exist and expanded our knowledge of the range of possibilities in the cosmos. Transit timing variations. Kepler's precise measurements of exoplanet transits allowed scientists to detect variations in the timing of these events. By studying these transit timing variations, researchers discovered the presence of additional planets in multi-planet systems, even if those planets were not directly observable through the transit method. This technique has been instrumental in characterizing the architecture and dynamics of exoplanetary systems. Starquake observations. Apart from exoplanets, Kepler also made discoveries related to stellar astrophysics. It observed stars that exhibited fluctuations in brightness caused by stellar quakes, similar to earthquakes on Earth. These observations provided valuable insights into the internal structures and properties of stars. As we bid farewell to the Kepler Space Telescope, we are left in awe of the extraordinary legacy it leaves behind. It was a cosmic pioneer, unveiling a universe brimming with distant worlds and captivating possibilities. From revealing the prevalence of exoplanets to discovering Earth-sized gems within the habitable zone, Kepler has forever changed our perspective on our place in the cosmos. Its observations have ignited our imagination and propelled us further on our quest to answer the profound questions that lie beyond.